same question.
Okay.
What was that?
Take a call. How about for one
No,
year?
no, it's not that homework.
Oh,
Homework.
yeah,
Oh,
yes.
yeah. The homework
The
is.
one about the end, yeah, about the end.
There should be one here. If not, take it. Yeah, do you mind after class if you ask? That's perfectly fine. In fact, because I know James and Morgan have a question about it too, so.
So that's about the entire. Oh, wait, I need another one. I don't know, I'm not gonna share.
Okay.
No, he's got it. Oh, no.
Thank you. You're welcome, sir.
I like taking them.
And then I'll assume we'll be here a little bit later, or eventually. I saw, for those of you guys that are in Calc too, I saw this one. It was, some of you guys might have this one for homework or something like that. Anybody remember doing that one?
Yep.
How many pages did that take you guys?
That
That was horrific.
I think it was page.
No way.
No,
You must have done it wrong.
No, that's
I must have.
No, because you're saying, that's the one where you have to split it up and then you just.
And you get like a coast to the sixth.
Yeah, that's like.
They get to use the power reducing formula twice on that. Man, I was helping someone in your class, and that problem literally took me about 5 minutes to do, which means it probably would have taken some of you guys like, about a half hour.
What are you trying to say?
It's a hard problem.
I got close to it, but I never took up the phone.
Yeah. Yeah, this one's just hideous.
The problem is when
I
you get
feel
the
bad
first
for
part
you.
wrong and then the next page and a
Right,
half.
yeah. I had a sign error because I punched it into Mathematica at first, and that's what the 5 minutes took me. Like, it took me about 3 minutes to do the problem and then 2 minutes to find my stupid sign error, which I actually did at the beginning of the problem. Because when I divvied it up and I distributed, and then I used the, what was it, the power reducing formula on this animal, I must have distributed something out wrong, because I was doing it so quickly. What's that?
I hope to never need that again.
Yeah, well, most of the time what people do is just plug that into Mathematica and get the answer from it. And, no, I'm saying that's a difficult problem. I feel bad for you guys. So that's what I'm trying to say. Alright, anyway. Okay. What do we have to do? We have to do induction. And then also what we're going to do is next Monday we're going to do induction again. Okay, so Monday we're going to finish up induction. Yep. And then we will review for our exam. And then guys, just a reminder about like the assignments and all that stuff, just in case you guys forgot. Assignment number 6 is going to be due on Monday next week. So I think that's the 17th, right guys? And then assignment number 7, that's going to be due on Monday, the 24th of October, by the way. Just making sure you guys know the right month for that. And then don't forget, guys, our exam is going to be on next Wednesday. Okay, so exam number 2, Wednesday, October 19th. Okay? All right. And basically, guys, it's going to be all the proof stuff that we've been doing, and then some of the sequence and series stuff. Okay? So, if you guys have any questions about anything beforehand,
Is this the test most likely to give you an aneurysm?
yeah, this is probably the hardest test of the semester. Most of the time, once students make it through this test, they're probably good for the rest of the semester. So, and I have a lot of confidence in almost everyone in here, except if you're wearing a green shirt. Oh, how about that? Oh, just as easy to put an F in just as an A or a B.
That's fine.
Okay. Other questions, guys, I can answer for anybody before we go ahead and get started with everything. Okay.
Did you grade the homework?
I did grade the homework, and I posted the grades, didn't I?
Yeah.
Okay, so I'll give those back at the end of class. So, and I need to post the solutions for those, don't I, guys? Okay.
Did you
So
post the solution for that one?
I did for I think assignment 4,
Yeah.
and I didn't for assignment
I
5 yet.
meant that last problem that we didn't do in the notes.
No, can you remind me, can you email me and remind me? There was one problem
I
I did that I
forget
didn't
when I
do.
leave.
I know, and then you'll blame me for forgetting too, so. But if somebody would remind me, there's 25 of you and there's one of me, so one person can remind me. Just email me and say, hey Chris, post that last problem, and I'll remember what you mean, that's all. Okay, other questions, guys? Okay, so, and I will post all the solutions, I think I just forgot, honestly, so just blame that on me, my bad. Okay. Yeah, we all do, like your parents. So, so I want to talk about mathematical induction. This is going to be the last topic that's going to be on our examination. Basically, guys, mathematical induction is when you can't prove something by utilizing indirect proof, if indirect proof doesn't work, okay? We can use this process called induction, and there's 3 steps to being able to do this. Most of the time we use induction to prove like a series is true, or if we try to prove a formula is true, okay? Not like even and odd, although we could prove using induction for even and odd. We can prove divisibility sometimes, but mostly just for series and sums like that. So we have this thing called a basis step, which is the easy step. You just basically plug in a small number in the domain, see if it works, okay? If you do that, you get at least 3 points out of 15 for the problem, okay? The hard part of the problem is step 3, okay? Step 2, you just basically say if the basis is true, you just assume that it holds true for any small value, okay? And you can't disprove it, okay? Then what you have to do is, mathematical induction says that if you can show it true for every case thereafter, in other words, if you can prove it for the case plus 1th case, then the formula must be true, okay? So, basically you just show it true for some small case, you assume it true because you cannot find a counterexample, then you prove it true for every case thereafter, okay? That's called induction, okay? Sounds like it's a bunch of crop, but it really is one of the most powerful mathematical methods that we're going to utilize, okay? So, mostly today we're going to take a look at series. Next time we're going to take a look at maybe divisibility and then inequalities, okay? So, let's just go ahead and show something that's, and I don't want to say any of these are basic because they're all pretty tough, okay? But I want to prove the following by mathematical induction. So I want to prove that for any integer n bigger than 1, 3 plus 6 plus 9 plus 12, in other words, if I add up successive multiples of 3, we can summarize it by this formula. Okay? And Art, I think you might have said on Monday, like an arithmetic sequence or series. That's actually what an arithmetic series looks like, the sum of that. Okay? So let's just go ahead and see if the sum of this arithmetic series truly is equal to this. Okay? So here's our proof. Alright, now, whenever we do our proofs, we start with a basis step, okay? And I'm just, again, just like we've done for all the other proofs, I'm just going to put in brackets stuff that's not necessary, but it could be helpful when you guys are going back through your notes. Alright, the basis says we have to show this true for a small value of n, okay? So let's just use 2, okay? Just because I don't like using 1, so I can show you guys what happens with 2. So, let's let n equal 2, okay? Now, 2 means, on the left side, I'm going to add up the first 2 terms, okay? So, I'm going to put this in brackets. On the left-hand side, this implies that you add the first 2 terms, okay? So does that make sense as to what n means on the left-hand side of the series? It just means that we're going to add 3 and 6. If n was 4, we would add 3 plus 6 plus 9 plus 12 on the left side. On the right side, we're just going to use direct substitution. Okay? A lot of students often, well not a lot, but some students often confuse what n means on the left-hand side. So on the left-hand side, we're going to get our first term, and we're going to have our second term, so that's 3 plus 6. On the right-hand side, I'm just going to directly substitute 2 back into the formula. So that's 3 times 2 times 2 plus 1 divided by 2. Okay? So over here, we just use direct substitution. All we have to do now is just do a basic computation, and I think everybody in here can see the left-hand side is 9. The right-hand side is going to be 6 times 3 divided by 2, which is also 9. Okay, so this would be 9 equals 9. Okay, and I'm not good at math, but that seems like it's going to be valid. Okay, so Guys, that's as easy as it gets, right guys? That's not even math. That's just like very, very simplistic substitution arithmetic. All right, if we can do that, we at least get 2 or 3 points for this problem, okay? Now, that's step 1. We've showed it true for the basis step. Step 2, okay? This is what we call the inductive hypothesis. Okay? And again, I'm just going to put this in brackets, so that way every time I talk about these things, you know what we're talking about. Okay. What we've seen is that this result holds for small values of n. Okay, so we're going to say this formula, or this result, holds true for small values of n. Okay? Because we have to state whether or not that the basis step actually does hold. Okay? If we don't write that out, then somebody that's looking at that doesn't necessarily know that the basis is valid. Okay? By the way, what happens if the basis is invalid?
Then we're gonna go
You're
for
done, right? We've actually found a counter example, okay? And you're really lucky, because then you don't have to do all this crap. All right, so now what we do is we, if you look back up at step 2 says that we assume the result holds for all n equals k, where k is an integer. So that's what we're going to do. We're going to say, let's assume the result holds for all n equals k, where k is an integer, okay? And I've just defined a new variable, so that's why I just put k as an integer there. Okay, so we assume the result holds true for all n equals k. So now what we can say is that instead of this formula, we just replace the n's with k's, okay? So thus, 3 plus 6 plus 9 plus 12 plus da-da-da-da-da, plus all the way up to 3k. And remember, we're assuming this holds true for all the k's, okay? We don't know if it holds true for the n's, but we're assuming it holds true for k's. Okay, so that's why we just change our variable here. 3k, k plus 1, divide 2. Okay. So, if you guys can do that much on the examination, I'm inclined to give you guys 4 or 5 points out of 15. Okay, so, and I'm going to have 2 problems that involve induction. They'll each be worth 15 points. Okay? Alright, so that's step 1 and 2. Okay, now we have to do step 3, where we have to show that the result holds for every case thereafter. In other words, let's let n equal k plus 1. Okay, so, we're going to prove for n equals k plus 1. Okay. So, let's do that. Let's let n equal k plus 1. We're going to substitute. Okay, so we're just going to say, let's let n equal k plus 1. By substitution, the formula that we have up top, okay, or this guy right here, so 3 plus 6 plus 9 plus 12 plus da-da-da-da-da plus 3n, which is equal to 3nn plus 1 divided by 2. And we're going to substitute k plus 1. Okay, now I'm going to show you guys what it means to substitute k plus 1. Okay, on the left-hand side, we're going to go up to the k plus 1th term. So the k plus 1 term is the term after 3n in this case. Okay, so this is going to become 3 plus 6 plus 9 plus 12 plus da-da-da-da-da plus 3k plus 3 quantity k plus 1. Okay? So basically, guys, all we're doing is we're just going up one more term than what the series gives us. Okay? Does that make sense to everybody, guys? Like, this term right here is the kth term. This is the k plus 1. So here's what I always tell people. I always tell people, just rewrite what you already have, and then just add on one more term where you put k plus 1 in for n. Okay? It's the easiest thing to do for that. Okay? On the right-hand side, we just directly substitute k plus 1 back in for n. So this becomes 3 quantity k plus 1, quantity k plus 1 plus 1. You could immediately write that as k plus 2 if you wanted to, divided by 2. All right. So let me make sure that's all okay with everybody. But did I lose anybody so far, guys? Any questions? I know it's a different type of animal. We might have to see it a few times before we truly assimilate it. But I just want to make sure everyone's good for this. So, obviously on the right-hand side, we can just write that as k plus 3k plus 1 times k plus 2. So let's just go ahead and do that. We'll make that nice and easy. K plus 1, k plus 2, div 2. That's just computation. What about the left-hand side? Is there anything that we might be able to possibly do to simplify the left-hand side? And if so, what?
3k plus 3, right?
Well, I don't want to combine like terms. Okay, that's
Okay.
okay. That's not a bad try. Donnie?
Just add up all the stuff right now.
We could do that, okay, but we don't know the stuff in the middle, right? So unfortunately, we don't know if that's going to be like 5 terms, 55 terms, 555, and it's not a bad guess. I think that's what both you guys were thinking, combined like terms, because that's what we've done all our lives.
What about subtract them? Those 3k and 3k.
One more time?
Expand what the 3.
No, that's actually what the gentlemen were saying too, they combined like terms. John?
Factor out of 3?
Unfortunately, not a bad guess, okay?
You subtract 3 times k plus 1
Um,
on both sides?
No, unfortunately not, okay?
Okay, so we're all...
Okay, that's all right. It's not a bad thing. I want you guys to notice that this stuff right here might be equal to something already that we know.
Oh, yeah, that's 3k.
Guys,
Let's
did
take
we
a
say over here that 3 plus 6 plus 9 plus 12 plus 3k, whatever, and however many terms that are in here, okay? And Donnie, I think you made a good point right here that we don't know if this is 5 terms, 55 terms, 555 terms, but whatever it is, it's got to be equal